So yeah, this is Wayne. He's going to be talking about audio in Unity 5. So prepare your ears. It's going to be pretty nice. And then after that, after a short break, we've got Fee talking about procedural games. So definitely hang out for that as well. And I guess I'll pass over to Wayne and let's get started. Cool.
Hello. My name is Wayne. And actually, I'm going to ask a question. Who here is like what they would consider themselves a bit of an audio person? Cool. Who thinks audio is a waste of time in games? Because I think that's like a perception that a lot of people, come across in the industry. But it's good that you guys are here and that we can talk about audio. Yeah. Today I want to talk about audio and Unity and where we're going with it, and I want to talk about some of the stuff that we're pushing to Unity 5. Me, I am Wayne. I live and work in the enemy territory in Copenhagen, and I originally worked at FMod. If you guys know what that is, it's like a middleware, audio middleware company, and I get to work on some pretty awesome stuff at Unity. Some awesome R&D, so yeah. So the future of audio and Unity. I guess we've recently renewed a push in Unity for audio and to make audio really awesome and next generation in Unity. We've rewritten a lot of the underlying audio asset pipeline and rewritten a lot of how audio clips work and how everything works audio-wise in Unity. With huge optimizations. So that was like the first initial layer that we did. We've changed and we're pushing more for UI-centric tools that empower sound designers. I think that before the audio in Unity was a little bit hidden, or kind of everything you needed to do, you had to go into script to do. And we want to address a lot of the gaps in functionality, like submixing and stuff like that you could never really do properly in Unity. We want to address those and then build on that to create things like interactive sound functionality and stuff like that. So I want to talk about this release though, the 5.0 release, and that's some stuff we've done in terms of the audio system and the new feature, the audio mixer. So, one of the first things that we did was we completely rewrote the way assets are imported now. That's done in a separate process, and it basically means that you can import arbitrarily sized audio clips into Unity, and it eliminates the chance of any sort of audio corruption, sort of bringing down Unity or anything like that. Unity only ever loads the processed data. And it means that the memory overhead of Unity is drastically reduced. And we've optimized the codecs that are used in Unity. So we got rid of MP3, which is kind of really an outdated and rubbish format. And we've implemented a new compression format called Vorbis Tremor, which is like a really super optimized implementation of an un-alt-wrapped Vorbis decoder. And we also added ADPCM target for compression. So I want to talk about those three compressions quickly, if any of you guys are not familiar with those. So PCM, I mean, that's basically raw data, and you can target that in Unity, obviously. It has no decode costs, and it's suitable for short sounds like footsteps and stuff that you don't want to have to worry about all the decoding costs or streaming or anything like that. There's ADPCM, so that has a constant compression ratio. It's really cheap to decode. I mean, it's basically almost like playing PCM data, but it's not really suitable for all sounds. It introduces some noise, and it's kind of good for natural sounds like outdoor ambiences, stuff like that, I guess. And I'll go through this a little bit in a second. And the Vorbis compression. It has the maximum compression ratio, which is super cool, but it has the heaviest decode costs, of course. but it's really suitable for anything. It's great for streaming, it's great for small sounds, large sounds, music, everything, voice. And the benefits of this new compression format is that it's much more performant than MP3, firstly. It's hugely more performant than Ogg Vorbis straight up. It has a really low memory footprint, and there's no artifacts that come along with other formats like MP3, like looping problems, stuff like that. So we got rid of all those issues. And I want to show you quickly, just so that you know, just so that you see the differences between the different compression formats. I have a sweeping tone here that I've imported into Unity. And here I have just PCM, straight PCM encoding, so raw data. You can see that there's no real artifacts. We have the 80 PCM compression. You can see that at high frequencies it starts to get a little bit wobbly. And there's a little bit of noise, especially through the whole spectrum. So as I said, it's really good for good compression, cheap, but you got to really pick the right assets that you want to compress to this type of sound. And Vorbis, which is, I mean, the noise ratio on this format is really, really tiny. So yeah, and I got this really colourful graph that I decided to make, showing the differences in memory. The middle one is basically the new codec that we use. It's super lightweight as compared to the original non-mobile target, Ogg Vorbis. So we're going to be saving you guys a lot of memory that way. And it's even better than MP3 for compressed in-memory sounds. We also added the ability for audio clips to not load their audio data when the scene loads. So I guess you guys know that when audio clips are loaded in Unity now, they load all the audio data unless they're streaming. And even if they are, they kind of allocate the stream as soon as the scene loads, which is kind of a little bit of a pain. So we've added the ability to not load anything. So the audio clips become these really lightweight objects that you can then interact with and build your own loading strategies to load in and load out of all the audio data as you need. And you can also do this loading blocking and non-blocking. So you can actually hold to Unity while the clip loads, or you can tell it to go away in the background and do it, and then just query if it's ready to play later on, which is super cool. And I've just got like a really simple example of how you would use this in script, loading and unloading. We also improved the voice management. So like I said, we really optimized the way resources are handled. We don't have any sort of sloppy, dangling resource management now. It's super tight in the way we handle all of our voices in Unity. We've improved the streaming. So we have basically proper streaming from any sort of source, so asset bundles, dub, in the editor, from disk, anything. So, and the streaming is really good. And yeah, like I say, the streaming inside the editor now replicates what happens in the game, which wasn't the case before. So you can actually you can actually profile the editor a lot easier now and see memory-wise what's going on. The audio clip information is really accurate now, so things like exact sample lengths and stuff like that is always available, and it's always accurate when you query it, and it can be done even without the data loaded, so all this information is cached. And we have really improved the audio profiler, well, the audio section in the profiler. So there's heaps of really useful information for you guys when you're sort of debugging the memory-wise your game. And something that's been missing is multi-edit of audio clips, so we sort of put that in now. Cool, so I want to talk about Audio Mixer. This is like our first big push for you guys, the first big feature that we want to get across and say, hey, we're really serious about audio now, we want to take it to the next level in Unity, and this is like our first offering. So yeah, and I guess like the first question is, if you're not hugely audio driven, what is an audio mixer? And an audio mixer kind of allows you to do really complex routing and mastering of the whole game soundscape. So you can imagine that you have a bunch of sounds playing, but you really want to tweak how each one of them sounds in the mix and how they all like play against each other to get a really nice sounding game with all the sounds in the game. It allows you to add DSP effects, so echo, reverb, anywhere in the signal chain now. And it allows you to really group or create groups of sounds, categorize them, apply attenuation, other effects, stuff. And you can do it all in the editor without having to obviously jump into any script. And what this really means is that you can actually master the game's mix while you're actually playing the game in the editor. So you can be playing through the game and someone can be actually mastering what's happening in the game and the sound of the game while you're actually playing it, which is super powerful and super quick in iterating through the mix. So what is it actually? It's a new asset type that you can create in Unity. As I said, it's got really extensive authoring tools, which I'll show you in a second. It's modeled on existing DAWs, or digital audio workstations, if you guys are familiar with that. And something that we've allowed is the ability to create and chain together multiple audio mixes. So we've kind of given the power to you, and it allows you to do really complex and weird and wonderful things with these audio mixes. So I'm just going to go through a quick example. As you see here, we've got an audio mixer here. It's an asset that you can see here. The groups are shown as sub-assets of the audio mixer. You can create the hierarchy or the mix hierarchy, the routing in this mix tree view, and these nodes or these mix nodes, they're shown as strips, and you can see this here, and you can arrange them and create views of those guys and stuff like that, which is super cool. And yeah, so like I can jump in the game and I can show you quickly how it would work and how you can edit it while you're playing. If I can play some music. You can mute while you. So now I can talk. I can mute. You can also solo different branches in your tree, and you can obviously play with the mix. So. You can add effects. And so on. So that's like a really simple overview, and now I'm going to go into depth with exactly how and why you would use this sort of stuff. So to do that, I want to talk about routing. And as I said before, routing is a way of, I guess, categorizing your sounds. So you can imagine you have groups of sounds in your game or groups of categories, and you may want to categorize them any way you feel. You may want to categorize all the weapons together, or all of level 1 sounds in a particular way. And it allows you to create categories of these sounds and then create hierarchies of these categories. And this is super powerful and allows you to do some really complex tricks, I guess, with how audio sounds and how audio is mastered in the game. The group hierarchy is mixed together until it hits the master group of a mixer, as you can see in the diagram. And basically that's like the root node of your audio mixer's signal flow. And from there you can either route that directly to the audio listener, or you can actually route that to another audio group of another audio mixer. So create, as I said, complex chains of effects and sounds. So this is like I guess like a a diagram of exactly what's going on. You can see that the audio source is playing into an audio group in an audio mixer. They all get mixed together, and they can either go to another audio group somewhere else, or they can go to the audio listener. So, audio sources can be routed to any of the groups, not just the leaf nodes, I guess, which is important. And just a side to this, scene graph related concepts. So mixing is, I guess, orthogonal to the scene, and it's very important that it's orthogonal to the scene, because audio generally, or it can be, but it's generally not related to the scene graph. But things like 3D attenuation, Doppler, and stuff like that, that's all applied at the audio source and calculated and at the audio source before the signal hits the audio mixer. So, and I'm just going to give you an example of creating one of these guys, I guess. So what I'll do is in my world here, I showed you before, there's no noise just standing here. There's footsteps which you can't really hear, so what we're going to do is we're going to boost those guys. And what we want to do actually is create some ambience feel to this level, I guess. So I've got a bunch of cricket sounds and songbirds and frogs and stuff like that, and I want to create I guess a mix of these guys. So what I can do is I can quickly just, as a quick example, just drag these guys into the scene, and what I want to do is create a new audio mixer, and I'll call this ambiences. And what I'll just for the sake of being able to mix this quickly, I'm going to make one group for each one of these guys. So and so assigning these guys is super simple. So you just go to your audio sources, and you can drag the appropriate group in. We've also implemented a really cool like hierarchical object chooser that you can quickly like search down to what you want. So, and the frogs, we'll just quickly do this. And let's jump in the game now, and we should, I guess. Oops. So I guess like we want to like play with the levels now and sort of make it sound as we want. So the crickets are a little bit loud. Okay, whatever. So that's how you would quickly create an audio mixer. But we actually have this. We want everything to go through this FBX mixer, because we want to do some cool stuff with this later, and I'll go through that later. But basically, the easiest way to do that is simply bring up your audio mixer that you want to route from, and select the group you want to route to, which I'm looking for, and drag it onto the destination. And now we should be able to select and see that it's playing through in a chain, which is really cool. Cool. So now I want to talk a little bit about effects. Now, effects, I guess, like a lot of you know what effects is, like echo or reverb, like I said earlier. But in Unity and audio mixers, you can add DSP effects anywhere you want. You can modify the effect parameters in the inspector for this group directly, which is super important because it allows, we also allow you to make snapshots, which we'll talk about in a minute. But you can do, we allow you to do partial mixing. So basically you can create a dry channel around any effect and decide how much of the signal you want to be, how much you want to be affected by the effect, and how much you want it to go around and not be affected by the effect. Effects are stacked and applied sequentially in an audio group. And in Unity, we're going to obviously give you a selection of effects that you can start off with right out of the, as soon as you install it. We also, so I have this diagram here showing you the group, how it's shown in the editor. Actually, we've improved the look a little bit, but yeah, basically showing how it is in the editor and a diagram of what's actually happening. So the voice is coming through the top. We're applying some effects, maybe another effect. Then we're doing some attenuation, or we're actually applying the volume at that point. Maybe some more effects after the attenuation. So this is really important for nonlinear effects like distortion. And then we take some metering information so that we can show you what's happening during playback. And then that gets passed out into the next group, and so on and so forth. We also have created the ability to do native plugin effects. So I guess it's really important that, I mean, we provide a few effects for you guys, but it's important that you guys need to be able to create your own effects, and not just in script. So developers can now create custom native DSP effects that you'll be able to just drop into your effects folder, your plugins folder, and then they'll immediately show up in your effects menu. You can define a set of parameters for this effect that will also automatically be shown in the inspector that you can tweak. And we also actually provide the ability for you to draw a custom UI for your plugin. So if you have a particularly weird plugin that doesn't really work with just sliders and you need to visualize something, we allow you to write a UI plugin like in C# associated with your native plugin. And yeah, it just all automatically works. And so you can start imagining that like developers, third parties can create like really cool custom DSPs. DSP manufacturers can start writing plugins for Unity. They can release it on the asset store, things like that. So these sort of ideas start like snowballing, and we can start like creating a good ecosystem of effects and stuff for Unity. So I'm going to go through a quick example. I have a, actually I'll just show you the code quickly. So this is like the callback code that you have to define. We just have a couple of callback functions that you need to implement. I have a multiband compressor here. And implement that, compile it down to a DLL, drop it in the plugin folder, and you're good to go. And here you can see that like we just have a standard on GUI call as you're used to, C# on GUI call, where you can draw whatever you want and associate it with parameters in your effect. So I guess like, well, I'll show you a quick couple of effects here. I'll jump into the game and play some music. Kill this guy. And then we can add, I guess, like a... Actually, what we'll do is we'll add a multiband compressor, which I just showed you. Also, you can we've got a few demo plugins that we're obviously going to release to you guys, and you can also do things like do synth plugins and stuff like that, obviously, which is really cool. So now you can just obviously, so this is like drawing a custom UI so that you can actually tweak it with sliders and stuff like that. So yeah. We also have things like, what do we have here? Let me just try that again. Like a roboticizing effect, which sounds pretty cool. So yeah, I mean, whatever. You can see that it's like pretty powerful with what you can do in terms of effects. So yeah, that's I guess an overview of effects. There's a lot more you can do with effects, I guess, but yeah. So now I want to talk about snapshots, and snapshots are, I guess, like if you've probably encountered them if you're in audio in various other names. But basically, snapshots allow you to capture the state of everything in the mixer, including the effect parameters, volume, pitch, ducking settings. I'll talk about ducking in a minute. But allow you to capture the state of the mixer, and essentially allows you to transition between these states during gameplay. So you can create really complex themes and moods in the mixer as snapshots, and then you can basically just easily transition between them or create like complex configurations of multiple snapshots that you want to blend between and stuff like that. So these snapshots, you can imagine like a really simple example is you create a snapshot that really brings down the mood and makes it dark inside a cave, and then as soon as you walk out into a field, you want the adventure music to come up and everything like that, and that can be done like zone-based or script-based or anything like that. So they're super powerful for doing, for basically like changing the entire soundscape with one call in script or with a component. Whole sections of the sound can be brought in and out, or even just like on a small scale, individual effects can be like dry channeled out, so they can be taken out or brought back in again. So what I'll do here is I'll give a really quick example of a snapshot. So when I talk about snapshots being powerful and you can do whatever you want with them, I'm going to create like a really weird situation where when I'm standing in place, my character, I'm going to like want to just play the ambiences. I want to play the crickets and whatever. And if I start running, I want to slowly bring in the adventure music. And as soon as I stop again, I'll play the crickets. So that's I can do that in like a few seconds here. By let's jump into the game. Let's do a mix. You can add the snapshot in. Let's call it running. Let's call the second one, I guess, static. When I'm in the when I'm in the running, I want let's play the music at the same time. When I'm running, I want to boost the music. And when I'm static, I just want to have the crickets. So 2 snapshots. Super easy. And then to basically enable this, I've created this this snapshot switcher, which is a few lines of code. It's like transition to running or transition to static, which basically gets the snapshot and says transition to me over a certain amount of time. So I can do that by simply dragging the snapshots in. So running to running, super easy. Static to static, 2 seconds, and we're done. So we're standing there. super cool. And you can imagine, like, I just did some volume changes there, but you can imagine maybe instead of changing the volume, I actually just changed like a low pass filter cutoff when I start running, or something like that, like whatever you want. Cool. And so I guess, like, when I talk about snapshots being for the entire mix, if you want to just reach in and be able to change like a really like one parameter within an effect somewhere within one of the groups, you can do that, and that's done by expose parameters. Oops. So you can expose individual effect parameters to script and give them a name. You can modify these parameters directly, so you can set them like directly paired with game logic. And it really allows you to do really fine-grained tweaking of like your mix. So if you want to reach in and change the cutoff of this particular low pass because you've created your own occlusion system or whatever, no problem. And just to show how simple it is, I got a quick example where you basically just get the mixer and set the exposed parameter value. We also implemented this feature called send and returns. Again, if you're audio guys, you'll know what a send and return is. But basically, send and returns allow you to send or branch off portions of the signal and send them to anywhere else or any other audio group, anywhere else in the audio mixer. So you can imagine, like, if you want to split the signal and apply some effects with one chain of the signal, and then maybe later on bring them back together and then snapshot how that sounds. These are the sort of things that you can start doing with snapshots, sends and returns and snapshots. So it's really powerful. It's like a really next generation for audio, for games at least, concept that we're bringing into Unity. It's something that you can combine with snapshots and make really complex mood transitions and stuff like that. And I'm going to give an example of how that would work. So we have a... well, I'll go back to my ambiences actually. And we know that frogs, I guess, they like to live in caves or like in dark, wet areas. So what we can do here is we can actually create a new group that we'll call a reverb group. And what we can do then is when the frogs are playing, we can actually send a portion of that signal to the reverb channel. And I can do that simply by saying I want the send to go to the reverb's return. And if I jump into the game actually now, you'll see that I haven't pushed the level up so that it's not sending anything. But we start sending some of the signal across to its sibling node. And then from there, I can actually do things like start applying these effects, like a reverb. So maybe we want to apply the reverb here, and let's just muck around with that a bit. So boost the reflection, boost the reverb. So cool. And you notice here. You notice here that actually my attenuation here, or my attenuation bar in the inspector, is not showing any signal going through it, and that's because the VU meter here is actually showing you what's happening at the attenuation point, whereas on the group here, the VU meter here shows you what's happening as it's coming out of the group. So you can see immediately that the return is actually happening, or I'm returning the signal after the attenuation. And so if I put it before the attenuation, you start seeing that there's signal going through, and that's when I can start attenuating that signal and doing whatever. So it's like super powerful for being able to not only debug what you're doing, so you can just drag the attenuation slider and see what's happening with your levels while you're playing the game. Sorry, attenuation block. But it also allows you to do complex, I guess, things where you don't want to have attenuation applied to stuff coming in after the attenuation block. Cool. So sends and returns. And now I want to talk a little bit about ducking. So one of the big things you want to do in games is keep the I guess the sounds audible, and usually that's done with ducking. So what that essentially means is it allows you to lower the volume of one part of the mix based on the signal of another part. So if I have, like, as an example, an NPC that's standing right here, and there's a whole lot of explosions and gunfire going on, but I really, like, the game is, it's important that I hear what he says. Ducking comes in and allows you to kind of compress everything else that's happening in the mix so that you can just hear what's happening, like, you can make sure that you can hear what he's saying. This is also known as sidechain compression. And Unity provides this for any audio group, so you can basically drop ducking in and have these really complex relationships right out of the box without any script code or anything. You can just set it up in the editor. So let's give a quick example. I've actually set one up already because I've kind of run out of time a little bit. But basically, we have a situation here where we want to play some music, and we know the ambiences, and then we drop a grenade into this world. And when that happens, we have an explosion, and we have some ringing effect that you would commonly get with a flashbang. And we want the mix of all of, I guess, the other parts of the soundscape to be brought down. So all you hear is the ringing and the explosion. And so you can see here that I've got, I'll just switch to the other mixer. I have implemented on the main bus here, I'm saying that I want to duck myself, so bring down the mix of my group based on what's happening in the SFX group. And I want to do that, and you can obviously choose the ducking amount, the attack time, the release time, so you can decide how long you want to duck for and how it's going, like the characteristics of how it comes in and out. And you can also choose the mode, so you can choose you can choose to directly measure the signal and decide how the ducking works. Radio ducking, or like loudness of the, I guess, like just calculating the loudness of the entire sub branch, which is kind of like just calculating the volume output based on all of the channels playing through that. It's kind of complex, but we obviously have documentation on this and all that sort of stuff. But so all you have to do is drop in. You can just choose the group that you want to duck by, and that's it. So as soon as anything starts playing through these groups, we should get some good ducking characteristics. So I'll play the music as well. Let's go back into the situation we had before. And let's drop some grenades in the world. So yeah. So that's, I guess, an explanation of ducking and how you can use it. So yeah, like this is another one of those really powerful features that we've just put right out of the box in the editor, and you can just drop into the game without having to write any script code or anything like that. So yeah, That's my talk. Thank you very much for listening and being here. And if you guys have any questions, shoot away.
Entire presentation, because for my project, myself and my sound designer have been spending several weeks implementing the exact same thing. Right. So I'm really pleased to see that actually coming into the next version of Unity. Yep. There's one thing that we use extensively in our project, and that's having random variations every time you play a sound. So 10 sounds becomes 100, and you lose that repetition kind of thing. Is there support for that kind of thing, or would you have to write a native effect to do that kind of thing? Or?
Right, yeah. So I guess like that's a really good question, and I guess like the answer to that is that for the 5.0 release, this is what we have, and I guess it's more targeting the ability to mix the signal or mix everything, right? The playing random variations and stuff, we're sort of going into something else which is more like creating interactive sounds where you can define parameters of how that randomization happens and stuff like that. And this, like I say, this is the first offering that we're giving, and our next like push is going to be towards the interactive sound front. So situations where you can create randomization and I mean a lot more music systems, dialogue systems, stuff like that. So this is I guess where we're heading next. But for the moment, I guess with 5.0, the interactive logic is still in the hands of you guys. So.
Cool, thanks. Yeah, I mean, even for the first version, it's amazing. So.
Yeah. Yep.
Just a quick question regarding the reverb algorithms. It seems like they were the same as before.
Yes, we still use the same reverb, I guess, which is underlying, like at the low level, is I guess the Fmod implementation. But what we want to do is basically allow you to drop in any sort of reverb you want, I guess, with plugins. And then what's the future from there is, I guess, the ability to use any sort of reverb. If you want to, like, it's really important that you have like a super complex convolution reverb or something, you can go ahead and do that. And then if you want to actually have that interact with the physical world via like exposing that effect and then, you know, interacting with it via whatever, I mean, that's where we're kind of heading with that. But at the moment, I guess the initial suite of effects and reverbs, it's just the same reverb effect from what we had before. Actually, all the effects that you had as components before in Unity, they're the same effects that you're basically dropping in, the same underlying algorithms that you're dropping into the audio mixer for the moment. Yep. Yes. Yeah. So basically, all of the calculations of like attenuation and pitch variation on Doppler and stuff like that, that all happens at the audio source because it's scene graph related, right? So, I mean, it's based on the physical world. So, the audio source still, I guess, decides where we're playing something from and how we're playing it in that 3D space. So yeah, all of those calculations are done and applied to the signal before they hit the audio mixer. Yep. Reverbs applied, well actually, yes, okay, so reverb zones are applied at the source as well, but again, we're moving to empower you guys to basically apply reverb anywhere in the signal in the future. Well, okay, so we've run out of time, but I'll obviously be just out here if you want to ask any more questions to me directly, and yeah, thanks very much.